Rationalizing the denominator. In mathematics, as a general rule, we write expressions without radicals in the denominator. For example, if we had 1 divided by the square root of 2, we would not generally leave it in this form. We would rewrite this into an equivalent fraction, and its equivalent fraction happens to be the square root of 2 over 2. The process of getting it from 1 divided by the square root of 2 over to the square root of 2 divided by 2. The process is called rationalizing the denominator. So the process used to rewrite a quotient to its equivalent form without a radical in the denominator is called rationalizing the denominator. Let's demonstrate this process of rationalizing the denominator using the example that we have above. So if we start with 1 divided by the square root of 2, and we want to remove the radical from the denominator without changing the value of the entire quotient, we're going to do this by multiplying the quotient by the square root of 2 over the square root of 2. This particular fraction equals 1. Any number divided by itself, or any variable divided by itself, always equals 1. Multiplying any fraction by the number 1 does not change its value, but it can change its appearance. So let's proceed. If we want to multiply a fraction by a fraction, we multiply numerator by numerator, denominator by denominator. So in our numerator we have 1 times the square root of 2, which is just the square root of 2. In our denominator we have the square root of 2 times the square root of 2, which is the square root of 4. But we also know that the square root of 4 is equal to 2. Our numerator stays square root of 2 since there's no way to simplify that particular square root. This is how we came up with our equivalent fractions. We multiplied 1 over the square root of 2 by the number 1, but the number 1 was written in a particular way in this case, and we ended up with a new expression equivalent to the one we started with. However, there's no radical in the denominator. Let's try a few more so we can see how we choose that equivalent fraction that equals the number 1. How do we go about choosing what that looks like? So here are a few more examples. Suppose we had 3 divided by the square root of 5. We want to rationalize the denominator. In other words, we want to get rid of the square root of 5. If I want to get rid of the square root of 5, I'm going to multiply both the numerator and denominator by the square root of 5. Again, remember, this particular fraction equals 1. So I'm not changing the value of my original fraction. I'm just making it look a little bit different. I'm turning it into an equivalent form. All right. Multiplying numerator by numerator, we have 3 times the square root of 5. Multiplying denominator by denominator, we have square root of 5 times square root of 5. Our numerator, we can write it as 3 square root of 5. Our denominator becomes square root of 25. But we also know that the square root of 25 equals 5. Our numerator is already in simplest form. So we have rationalized our denominator. Notice the denominator no longer has a radical sign. Another example might be 2 divided by the square root of 6. To rationalize the denominator, we want to remove the radical sign from the 6. We need no radicals in the denominator. In order to do this, we're going to multiply both the numerator and denominator by that radical we choose to remove. Because square root of 6 is in the denominator, that's what we're going to choose to multiply the numerator and the denominator. Here we go. 2 times the square root of 6 is 2 square roots of 6. In our denominator, the square root of 6 times the square root of 6 is the square root of 36. But our denominator now simplifies to be 6. Our numerator, 2 square roots of 6. Now notice, in our fraction that we have here, the 2 outside of the radical sign and the 6 in the denominator, that particular fraction can be reduced. 2 goes into 2 once. 2 goes into 6 3 times. This gives us 1 times the square root of 6, or square root of 6, divided by 3. So this is both rationalized and in reduced form. Can we have variables in our denominator under radical signs? Sure we can. If we want to rationalize 4 divided by the square root of a, the square root of a is in the denominator. That is the square root that we're looking to remove, the one in the denominator. So we're going to multiply both the numerator and the denominator by the square root of a. So in our numerator we now have 4 times the square root of a. In our denominator we have the square root of a squared. Simplifying our denominator we get a. In our numerator we have 4 times the square root of a. Now looking at the 4 in front of the square root in the numerator and the a in the denominator, these cannot be reduced. So this is our final answer. Let's try one that's a little bit different. We have 3 divided by 2 times the square root of 2. In this particular case, in our denominator, we have a square root of 2 that we need to rationalize. The square root of 2 is what we're trying to remove from the denominator. So, just as before, we're going to multiply both the numerator and the denominator by the square root of 2. The 2 on the outside of the square root we're going to leave in our problem. So our numerator becomes 3 times the square root of 2. In our denominator we have the 2 that was outside the square root, and then multiplying the square root of 2 times the square root of 2, we have the square root of 4. However, the square root of 4 is the same as 2. These are the same. But don't forget, see, we have that original 2 there. It stays with us in our problem. Now, my denominator is 2 times 2, which is 4. My numerator is 3 square root of 2. My final answer is 3 square root of 2 divided by 4. Now, how am I sure this is my final answer? The 3/4 cannot be reduced anymore. It's already in its reduced form. So this is my final answer. Here's an example where we have a fraction underneath the square root sign, the entire fraction. Well, how would we approach this one? We have a property that we previously learned says I can rewrite this fraction as the square root of 7 divided by the square root of 3. Now this is the fraction that we're going to rationalize. To rationalize, we are trying to remove the square root of 3 from the denominator. So we're going to multiply both the numerator and the denominator by square root of 3. We're okay with having square roots in the numerator. We just want to rewrite it without the square root in the denominator. So looking at our numerator, we have the square root of 7 times the square root of 3. which is the square root of 21. Our denominator, square root of 3 times the square root of 3 is the square root of 9. But the square root of 9 is 3. Our numerator remains square root of 21. Be careful here, you cannot reduce the 21 under the square root symbol with the 3 in the denominator, because the 3 in the denominator is no longer under the square root. If both of them were under square roots, then you could reduce them. However, one is and one is not, so this one is our final answer. This is as reduced as it gets. What do we do if we have a problem in which there is a sum or difference in the denominator? What do I mean by this? What if we had a problem that looked like this? 3 divided by the quantity 2 minus the square root of 6. We have a slightly different approach to this problem than our previous problems. Our goal is still to remove the square root of 6 from the denominator, but multiplying both the numerator and denominator by square root of 6 is not going to do it. In this case, we're going to use something called a conjugate. A conjugate is found by changing a sum to a difference, or a difference to a sum. For example, the conjugate of 1 minus the square root of 2 is 1 plus the square root of 2. The conjugate of 3 plus the square root of x is 3 minus the square root of x. Notice the only difference is our sum becomes a difference, or in this first example, our difference becomes a sum. That's how you determine a conjugate. So going back to 3 divided by 2 minus the square root of 6. If we want to sorry about the phone ringing. If we want to rationalize our denominator, we're going to multiply both the numerator and denominator by the conjugate. So the conjugate of 2 minus square root of 6 is 2 plus the square root of 6. And we're going to multiply both the numerator and the denominator by that conjugate. So my numerator becomes 3 times the quantity, 2 plus square root of 6. Using the distributive property, we have 3 times 2 is 6, plus 3 times the square root of 6. Now, in our denominator, we have 2 minus square root of 6 times 2 plus the square root of 6. In order to take care of our denominator, we're going to have to FOIL our denominator. FOIL is when you have a binomial times a binomial. The F in FOIL stands for the first term times the first term. So 2 times 6 is 4. The O stands for outside term times outside term. So 2 times a positive square root of 6, which is, there we go, is plus 2 square roots of 6. The I stands for inside term times inside term. So we have a negative 6 times 2, or minus 2 times square root of 6. And then L in FOIL stands for last times last. And we have a negative square root of 6 times a positive square root of 6, giving us a negative square root of 36. So F was first times first, O was outside times outside, I was inside times inside, and L was last times last. Now, we can clean this up a little bit. We still have 4. However, you'll notice that the positive 2 square root of 6 and the negative 2 square root of 6, add those together because they are alike. Remember, they're alike because of the radical part is the same. So we add the coefficients. Positive 2 and negative 2 make 0. So the middle term becomes 0. The last here we've got minus square root of 36. So minus 6. 4 minus 6 is negative 2. So our denominator, using the process of FOIL, becomes negative 2. We've rationalized the denominator because we no longer have a square root in our denominator. And we did that by using the conjugate. Now sometimes you'll see this last answer here written a little bit differently. So this is a possibility. Or you may see it as negative 3 minus 3 halves times the square root of 6. These again are equivalent expressions. All I did was take the negative 2 in the denominator and do 6 divided by negative 2, giving me the negative 3. This part here is my negative 3. And then this part here is negative 3 halves times the square root of 6. In most cases, this one is generally accepted. 6 plus 3 times the square root of 6, that entire quantity divided by negative 2. All right, one last example. Let's rationalize four minus the square root of 3 divided by 4 plus the square root of 3. To rationalize our denominator, in this case, we have a sum in the denominator. So we need the conjugate. The conjugate is going to be 4 minus the square root of 3. So we're going to multiply both the numerator and the denominator by 4 minus the square root of 3. Remember, this quantity here is always equal to 1. So in our numerator, we have 4 minus square root of 3 times 4 minus square root of 3. In our denominator, we have 4 plus the square root of 3 times 4 minus square root of 3. Now this time we have to use FOIL for both the numerator and the denominator. FOILing the numerator, we have 4 times 4, first times first, which is 16. We have outside times outside minus 4 square root of 3. Then we have inside times inside. It's another minus 4 times square root of 3. And then we have last times last. Negative square root of 3 times negative square root of 3 is a positive square root of 9. Okay. So, what happens here with our middle term in our numerator? Minus 4 square root of 3 minus another 4 square root of 3 is minus 8 square root of 3. And over here, what is our plus square root of 9? Well, that's plus 3. Simplifying our numerator, we can add the 16 and the plus 3, giving us 19. Then minus 8 times the square root of 3. Can I simplify my numerator by doing 19 minus 8? The answer would be no, because the 8 has a square root of 3 multiplied by it. This would not be a like radical with 19. Only if 19 also was being multiplied by square root of 3 could you subtract the numerator. So my numerator is complete. Now, let's FOIL the denominator. We'll do 4 times 4, which is 16. 4 times negative square root of 3, negative 4 square roots of 3. Positive square root of 3 times 4 plus 4 square root of 3. And then square root of 3 times square root of 3, positive square root of 3 times negative square root of 3 is a minus square root of 9. Negative 4 square root of 3 plus 4 square root of 3, this one equals 0. the minus square root of 9 is minus 3, so we have 16 minus 3, which is 13. There's no more reducing that we can do in this problem. 19 over 13 has nothing in common to reduce it. Negative 8 over 13 also has nothing in common to reduce it. So this is my final answer. Hope you enjoyed this lesson.